Let's be honest, when you hit send on an email or click on a link, you probably don't think about how it gets there. You just expect it to work. Well, behind the scenes, there's this invisible, absolutely critical set of rules that quietly runs the entire global internet. Today, we're going to pull back the curtain on that protocol.
I mean, really think about that for a second. How does a little packet of data, your email, a video, whatever, navigate this impossibly complex web of networks stretching across the entire globe and show up almost instantly? It feels like magic, right? Well, it's not. The answer to all this magic is a protocol called BGP. It's truly the unsung hero of the internet, the global GPS for all of our data. And in this explainer, we're going to break down exactly how this incredible system works. All right, so here's our roadmap. First, we'll start with a simple analogy to get our heads around the concept. Then we'll look at the actual building blocks that BGP connects. After that, we'll dive into how it makes its decisions, what happens when things go wrong, and finally, the huge security puzzle it faces today. Okay, so to really understand BGP, let's just forget about all the technical jargon for a minute, all the packets and routers, and instead think about something we all know, the Postal Service. And you have to love this origin story. Back in 1989, the entire core design for BGP was literally sketched out on a couple of napkins during a meeting. It wasn't some grand, complex blueprint. It was a practical fix for a problem that was getting bigger every day. And that simple, pragmatic approach is still at its heart. So here's the key idea. BGP isn't the delivery truck. It doesn't actually carry your data. Instead, it's the master directory, the logistics department for the entire internet. It stands at every major digital crossroads and tells all the data carriers, the ISPs, the absolute best routes to take to get their packages to the final destination. So, if BGP is managing the highways, what are those highways? To get that, we need to understand how the internet is actually structured. It's not what you might think. You see, the internet isn't one gigantic, single network. Not at all. It's actually a massive collection of thousands of individual networks called autonomous systems, or ASS. Think of Comcast, Google, AT&T, or even a large university. Each one operates its own AS. In our postal analogy, each one of these is its own independent postal district. And because of this structure, BGP actually has to do two different jobs. First, there's External BGP, or eBGP. Think of this as the International Postal Service, handling the mail that goes between different countries, or in this case, between different autonomous systems. Then you have Internal BGP, or IBGP. That's the local mail service, making sure all the post offices within a single district have the same up-to-date map. Okay, so if BGP has this giant map of all the possible routes data can take, how in the world does it decide which one is the best? Well, this is where the real genius of the protocol kicks in. See, a lot of routing protocols just look for the fastest link, the shortest physical path. But BGP is way smarter than that. It's what's called a path vector protocol. That means it looks at a whole bunch of other factors. Network administrators can actually program their own rules based on business deals, things like cost or preferring a route through a partner network. It's as much about policy as it is about performance. So here's a super simplified look at how a router thinks. First, it checks its own internal rulebook. That's the local preference, to see if there's a business reason to prefer one path. If everything's equal, it then looks for the path that has to jump through the fewest number of networks, the shortest AS path. And if it's still a tie, only then does it start using a list of more technical tiebreakers to finally pick the one single best route. It's a very deliberate process. Now, of course, a system that's responsible for the entire planet's internet is under a mind-boggling amount of pressure. It has to be stable, and it has to be able to grow. But sometimes, it breaks. One of the classic headaches for network engineers is something called route flapping. Imagine you're driving, and the highway sign for your exit is just flickering on and off, on and off. It would cause total confusion, right? Well, that's what route flapping is for the internet. A path becomes unstable, and every time it changes, it sends out an update, which triggers more updates, creating this massive ripple of instability across the globe. And a perfect real-world example of a BGP failure was the 512K day crisis back in 2014. For years, the internet's global address book, the BGP routing table, was just getting bigger and bigger. Well, on August 12th, it finally tipped over the 512,000 route mark. The problem was, a lot of older routers had that number as a hard-coded memory limit, so they just crashed.
The whole system overloaded, causing massive outages for huge companies. It was a really stark reminder that the internet runs on actual physical hardware with real limits.
And if you think that was a problem back then, well, that scalability challenge has only gotten more intense. The BGP table never stopped growing. In fact, as of today, we've blown past 1 million routes. 1 million. This constant, relentless growth puts unbelievable pressure on network operators to keep up.
Which brings us to our final and maybe the most critical topic of all, security. Because the one thing that made BGP work so well in the beginning, well, it's now its greatest vulnerability. You have to remember, when BGP was designed, the internet was basically a small club of researchers and academics. Everybody knew everybody. So the protocol was built on a very simple and very powerful idea: trust. By default, a BGP router just believes the route information it gets from its neighbors. There's no built-in ID check. This trust by default model opens up a huge vulnerability called BGP hijacking. This is where a network operator, either by accident or on purpose, announces that they have the best path to a destination that they don't actually own. And because of the trust model, other routers believe them. This can be used to spy on traffic or just send it into a black hole. Famously, in 2008, Pakistani accidentally did this for YouTube's traffic, effectively taking the site offline for much of the world for hours.
And so that leaves us with the fundamental challenge facing the internet's core today. The map that guides every single packet of our data was drawn up for a friendly, small-town world that just doesn't exist anymore. The million-dollar question now is, how do we protect that map from bad actors without breaking the very openness that made the internet so powerful in the first place? That is one of the biggest puzzles that engineers are trying to solve right now.